practice evaluating limits numerically and graphically. So, again, we just talked about to take a limit from the left, this notation here, and then we also talked about what it means to take a limit from the right. And we also talked about what it means for a limit to exist. It means that the limit from the left and the limit from the right must both approach the same value in order for the limit to exist. Okay? So there's also a limit definition in the textbook. It's very formal. You can read it and try to understand it if you want. I don't want it to confuse you, so we're not going to go over it in the video, but that might be something you want to take a look at. Okay, so here's an example. It says find the limit L. Okay, so why don't you guys go ahead and think what you think the limit is, knowing what we know about limits. What we can do is we can actually use direct substitution here to just plug in 2 for x, and we get 3 times 2 plus 6, which is 6, plus 2 is 8. The limit is 8 here, and, we can verify the things that we know that must be true in order for a limit to exist, such as the left-hand and right-hand limit being the same value. We can verify that on the calculator. I plug this in. I go to my table. I'm looking at the values as I'm approaching 2 from the left. Those are clearly approaching 8. And I'm looking at the values as I'm approaching 2 from the right, and those also approach 8. So, and we could also look at the actual graph of it, and looking at 2, right, I can totally see that coming from the left and the right on my graph, that it approaches 8. Okay, so now you're actually given this graph. It's a cool looking graph here. I want you to evaluate these limits. Notice that some of them are approaching from one side or the other, and then some of them are just approaching in general, and also ask you to evaluate some function values. So go ahead, put me on pause. So let's take a look here. So let's start with the first one. It says the limit of f of x as x approaches -4. So I'm looking where x is -4, and I notice that coming from the left-hand side and from the right-hand side that they both approach -3. So therefore, I just said the limit as x approaches -4 coming from the left is -3. Now looking at 0 here, maybe I should use different colors. Looking at 0 here, it is approaching the same value coming from the left and the right. That approaches -1. The limit as x approaches -3. Now here's -3. But notice that the left-hand limit and the right-hand limit don't approach the same value, so that does not exist. Next one. At 1, same idea here. It approaches the same value, which is 0. Now at -3, coming from the left, that approaches -4. The limit as x approaches -1, well, look at your left and your right-hand side. They don't approach the same thing, so that does not exist. The limit as x approaches -1 from the right-hand side, coming from the right-hand side, it's approaching 0. And then the value at -4 is -3, that's defined. But the value at -1 is not defined. That's an open circle, so it does not exist. Okay, so limits, again, check what the y value is approaching at a given x value, and we can use the graph, which is actually something I enjoy doing, and we could also use the table.